Software engineering is going through a massive, undeniable paradigm shift right now. I mean, artificial intelligence isn't just a shiny new toy anymore, right? It is fundamentally rewriting how we design, build, and maintain applications. But, and this is a big but, with all this incredible power comes a completely new landscape of hidden risks. We're talking subtle vulnerabilities and complex biases that can literally compromise your entire system if you aren't paying close attention. Okay, let's dive into this, because today we are going to look way past the hype and explore the rigorous professional standards you absolutely need to use AI safely in production.
Here's our roadmap for today's explainer. We'll start with the AI development revolution, then look at the primary risks of AI, move into identifying and managing bias, cover maintaining code security, and finally wrap up with professional AI workflows.
Let's kick things off with Section 1, the AI development revolution. The sheer scale of adoption we're seeing out there is just staggering. Look at these numbers. A 92% adoption rate among US developers using AI coding tools, with users reporting they are finishing tasks 55% faster. To put that into perspective, this is not just some fringe trend anymore. It is an immediate professional necessity. AI is taking away that heavy cognitive load, it's automating all the boring boilerplate code, and it's seriously accelerating the learning curve for junior devs. But we have to remember, speed without control, that's just a recipe for disaster.
And that brings us to a really critical distinction in how people are actually using these tools day to day. On one side, we have what's playfully being called vibe coding. You know the drill. It's a mode of high trust, low inspection. Developers iterate rapidly through prompts and basically just accept the AI-generated code without really reasoning through every single line. Now, hey, that's fine for a quick prototype, but the professional standard, that requires rigorous review, validation against tight specifications, strict security testing, and comprehensive documentation. If you're working in a regulated domain like finance or healthcare, vibe coding is a massive liability. No way around it.
Which brings us to Section 2, primary risks of AI.
See, the raw power of AI brings an entirely new threat model to software development. The core risks we absolutely have to manage include bias in our AI models, which can seriously skew automated logic and outcomes. Then there's the very real danger of over-reliance. Listen, developers who accept AI output blindly are going to suffer from skill atrophy. They will slowly lose their foundational debugging skills. Add in a severe lack of transparency in how these models actually make decisions, plus broader industry concerns about job displacement, it's a lot. But the most immediate pressing technical threat, that would be security.
Now, what's really interesting about this slide is the staggering vulnerability rate. A Stanford study found that roughly 40% of AI-suggested security-critical code contained vulnerabilities. Just let that sink in for a second. 40%. Blindly trusting AI output isn't just lazy, it's genuinely dangerous. We have to actively mitigate things like context blindness, which is where the AI simply doesn't know your organization's specific domain rules, and prompt injection, where malicious content can literally hijack and redirect the AI's behavior entirely.
Moving right along to Section 3, identifying and managing bias.
So what exactly does AI bias look like in the trenches of application development? Well, if the data used to train your AI models contains biases, the AI doesn't just mirror them, it perpetuates them, and in many cases, it actually amplifies them. When you're building software systems that handle user interactions or make automated decisions, think things like loan approvals or hiring algorithms, this bias leads directly to unfair, inequitable, or even discriminatory outcomes. And those carry serious real-world consequences for your end users.
To systematically neutralize this bias, we need concrete, technical mitigation strategies. First up, you have to rigorously audit your training and input data for diversity and fair representation. Second, integrate automated bias detection tools directly into your daily workflow so you can catch those skewed outputs early on. And third, and this is absolutely crucial, maintain regular human oversight and fairness reviews. You simply cannot automate accountability. It always needs a human in the loop.
Let's transition to Section 4, maintaining code security. Probably the biggest trap in AI-assisted development is what we call code hallucination. This happens when an AI generates code that looks perfectly formatted and honestly highly convincing, but it actually contains deeply incorrect or insecure logic. Because it looks so good on the surface, subtle security flaws can super easily slip past a tired developer on a Friday afternoon. These flaws often lie dormant right up until runtime or edge case testing triggers a catastrophic failure.
So how do we fight this? Human oversight is totally non-negotiable for code security. First, you must mandate critical human code review. I'm talking about actually reading every single generated line. Next, conduct rigorous manual security audits specifically targeting those common AI blind spots, things like SQL injections or cross-site scripting. And finally, enforce automated security scanning directly inside your continuous integration and continuous deployment pipelines. Lock it down.
To make all of this practical, let's look at the definitive 5-phase professional AI-assisted development workflow. It kicks off with context loading and decomposition, but I want you to pay special attention to Phase 3, generate and critically review. This means you are generating code 1 unit at a time and manually checking for security implications as you go. Then, right after that, is Phase 4, test and validate. The golden rule here? Do not accept generated code that cannot be verified against a strict specification and passing unit tests. Period.
Wrapping up our core topics with Section 5, Professional AI Workflows. If you want professional results, you need professional prompting frameworks. It's that simple. Let's break these down. Use Trace when you're dealing with requirements documentation and user stories. For actual code generation and step-by-step debugging, the RASCEF framework, which stands for Role, Actions, Steps, Context, Examples, and Format, is incredibly powerful because it literally forces the AI to match your specific tech stack. Doing client-facing proposals? Use CoStar. And for complex data model design or architectural trade-offs, use Chain of Thought to force the AI to explicitly show its reasoning steps.
And this brilliantly illustrates how those frameworks come to life. When you combine them with context-first prompting, you establish strict domain rules right out of the gate. Take this Python example. The developer establishes the exact tech stack, coding standards like PEP 8, and specific business rules, like capping class enrollment at 35 students, all before even asking the AI to write a single function. Without this upfront context, the AI defaults to generic and often vulnerable patterns. By explicitly defining custom error types and setting that context, you prevent context blindness and practically guarantee a secure architecture.
Finally, none of these workflows matter one bit if you can't reproduce your results. Enter the prompt diary. This is a structured log of the prompts, context blocks, and generated outputs that you maintain throughout your project. Why is this so essential? Because AI sessions are stateless. The AI remembers absolutely nothing between sessions. Treating your prompts just like code and version controlling them ensures reproducibility, stops your team from duplicating effort, and gives you a vital audit trail for compliance, especially in regulated industries.
As we wrap up this explainer, I want to leave you with a critical question to evaluate your own daily workflow. Think about it. Are you driving your AI tools, or are they driving you? AI is a massive, incredible accelerator, but without rigorous review, structured frameworks, and professional discipline, honestly, it's just a faster way to write bad software. Stay disciplined out there, review critically, and use these tools to elevate your engineering standards, not lower them. Thanks for joining me today.